Hi grade 9s, welcome to another one of our video lessons. Today we're going to carry on with activity 11.2 on page 102. Okay, remember from last lesson we covered Pythagoras' theorem, which said that if we have a right angle triangle and we take the hypotenuse, which is the longest side, and we square that, that will equal to the sum of the sides squared, or the other two sides. Okay. So basically, a squared plus b squared equals to c squared, where c is the hypotenuse. Okay. All right, guys. So you had to work through 11.1. I'm sure that was all right. We'll chat about it in the Skype session. But now let's continue with exercise 11.2, and then we're going to cover the converse to the Pythagoras theorem. Okay. Right. So for number one, we give you a bunch of triangles, and it's more or less the same thing what we did in Pythagoras in the last exercises. So I'm going to do this for one of the triangles with you. I'll run through the exercise and you guys are going to do the rest. Okay. Right, so number one, it says A, determine with reasons the values of W, X, Y, and Z. Leave your answers in simplified surd form where necessary. Okay, surds are numbers that look like this, like a root 2 or a root 3 or a root 5, something that we cannot simplify further. So like a root 16 is not a surd because root of 16 is going to be 4. But root of 2 and root of 3 and root of 5, root of 7 are all surds. Okay, so when they say leave your answer in surd form, you can leave your answer as a root 2, root 3. I don't want you to do that on your calculator and give me decimals. Okay. All right, so let's look at the first one. So they want us to find the values of W. So we got a right angle triangle with sides 7 and 9. Okay, so 9 is the hypotenuse, 7 is the bottom side, and the unknown side is W. Okay, so that's what they give us. Guys, remember that every time there's a right angle triangle, the theorem of Pythagoras holds. Okay, so that's what we're going to use to find our W. So Pythagoras says hypotenuse squared, which is 9 squared, equals to W squared plus 7 squared. Okay, so we just have to solve for W squared. So 9 squared is 81. I'm going to take this 7 squared to the other side. 7 squared is 49, so it's going to come across, so it will be minus 49 equals to W squared. Now, 81 minus 49, so I'm going to swap them around, so I'll say W squared equals 81 minus 49, that's going to be what? 32. So, no, 31. No, I think it's 32. Okay. Let's check. 49 plus 32. 9 plus 2 is 1. 1, that's 8. 81. Yes. Okay. Right, so W squared is 32, and then we have to take root of both sides. Remember, the square root cancels with the square, so that gives us W, and that equals root of 32. Okay. Now, we need to give the answer in simplified surd form. 32 can be simplified because think about perfect squares, right? Perfect squares are 4, 9, 16, 25, 36, and so forth. So can we break up this 32 into something else that can be a perfect square and something else so that we can take the root of the perfect square? Guys, remember we did this in grade 8, okay? So you do know this. If you don't remember, go back to your grade 8 books, okay? So what I'm going to say is W equals to root 32 can be written as 4 times 8, right? Now, remember, we can break this up as root 4 times root 8, okay? Well, actually, an 8 is also 4 times 2, so we can even say this 4 times 4 times 2. and then it will be root 4, root 4, root 2. Okay, and that equals 2. Root of 4 is 2, root of 4 is 2. So it's 2 times 2 times root 2. 2 times 2 is 4, root 2. So the answer is 4 root 2. And that is now a simplified surd form answer. Okay. So actually another way to do this would have been if we just went and said 32 is 16 times 2. And that would be root of 16 times root of 2. Root of 16 is 4 times root 2. Okay, because 2 is a prime number and we cannot break it up into composite numbers. Okay. All right, guys, so that's our W for number 1. I want you to do the rest for the other triangles. Then it says calculate correct to 2 decimal places where necessary the perimeter and area of these triangles. Okay, so JKL, perimeter and area. So this W side is 4 root 2. So perimeter P is going to be, add all the sides together. So it's 9 plus 7 plus 4 root 2, which will equal to 9 plus 7 is 16 plus 4 root 2. Guys, I'm happy with an answer like this because they asked us for simplified surd form. There it is. Okay, 16 plus 4 root 2. That's fine. Right, what about the area? Let me rub this out here. Okay, so area of a right angle triangle is half base times perpendicular height. Okay, so area equals a half base times perpendicular height. Remember, base and height has to have the 90-degree between them. We cannot use the hypotenuse as one of the sides, either base or height, because it's neither perpendicular here nor here. Okay, so we're going to use our other two sides. So base, let's take this, which is 7. A half times 7, I'll say over 1. Okay, let me just write that better. 7 over 1. And height is going to be 4 root 2 times 4 root 2 over 1. Okay, now I need to just multiply that out. I can see that that 2 can cancel with that 4. So I cross that 2 out, get a 1. Cross that out, get a 2. Everything is 1 at the bottom. At the top, I have 1 times 7 times 2. So that's going to be 14 root 2. 14 root 2. And what is it? What units are we working with? Did they give us any units? No, they didn't give us any units. So for perimeter, we'll say this many, put it into brackets, units. Okay. Guys, you have to say units because it's obviously measured in some kind of units, and we have to have square units as well. So if we don't mention what centimeters, millimeters, you just say units, and here 14 root 2 units squared. Okay, and then you're always correct. No one can mark you wrong on anything. Okay, right, guys, so that is area perimeter. And then for C, determine the area, the ratio of area of triangle ABC and area of triangle EDF. Okay, so what you're going to do is you're going to get an area of one triangle, you're going to get an area of another triangle. Okay, so let's say we get 4 root 2, and this is area of one triangle that we just worked out, or whatever it was. It's just an example, not the example. And then you want to find the ratio to another area. Let's say this is 8 root 2. Okay, so how do we now simplify this ratio, right? Well, remember, we're going to divide by the same thing, right? Because 4 to 8 is the same thing as 2 to 4, same thing as 1 to 2. Okay, so we just divide both sides by the same factor. Okay, here we can see that we have a root 2, we have a root 2. So we can divide by root 2, divide by root 2. They both cancel, we get ratio of 4 to 8. Okay, well, divide that by 4, we get 1. Divide that by 4, we get 2. Well, that is the same thing as ratio of 1 to 2. Okay, so once you work out those two areas, write them next to each other, whatever your answer is, and see what you can divide by. Okay, try to get this first ratio to be 1 if you can. Okay, we'll obviously go over the answers. Well, you guys can go over the answers at the back of the book, and then if you don't get it right, then you can ask me. Okay. Right, guys, so that is number 1. Number 2 is now looking at parallelograms, parallel lines. We've done all of this stuff last year, and we've covered all of these shapes. We've done the 3 different angle types, or alternate, cointerior, and corresponding. So look at exercise question 2, 3, and 4, and just give those a try, and we can go over them next time. All right. Right, now we can get to the converse of the Pythagoras theorem. So let me just have a sip. Some green tea. Right, so guys, the converse of Pythagoras theorem is basically, or any converse, is saying things backwards, right? So remember, what was our assumption in the Pythagoras theorem? That we were given a right angle triangle. Okay, so if we were given a right angle triangle, then c squared equal to a squared and b squared. Okay, but what if they don't equal? What if we get a triangle and we see that c squared does not equal to a squared and b squared, and we don't know if it's a right angle triangle or not? Well, that's how we're going to check. So if we are given a triangle, let's say here's a triangle and I haven't drawn it according to scale, okay? One of these angles might be a 90 degrees angle, it might not be, okay? But all I know is that there's some distances, say 5, 6, and 7, okay? Those are distances, and now I ask you the question, can you tell me if there is a right angle in that triangle, or if that's a right angle triangle? Well, we can check by using the Pythagoras theorem. We can find the longest side, because that is the hypotenuse in a right angle triangle, and we'll see that if that side squared equals to that squared plus that squared, then it is a 90 degree angle. But if it doesn't, then it's not a 90 degree angle. Okay, so there's a little formula that I want to write out and show you. So we can actually go beyond just saying whether it's a 90 or not a 90. We can say whether it's an acute or an obtuse angled triangle. Okay, so I'm basically looking at page 103 on right at the top. Okay, so it says we have an acute angled triangle if p squared plus r squared is greater than q squared. Okay, guys, so in the previous example, they used A, B, and C. Now they're using P, R, and Q, okay? So the Q is obviously the hypotenuse, and you can look at the diagrams right at the bottom, okay? Remember, the small letters represent the sides opposite the angle. So your Q, your small q, you can see is opposite the angle, or rather point Q. All right, cool. So we have an acute angle triangle if the two sides are greater than the longest side, which is the hypotenuse. Okay. Then we have a right angle if p squared plus r squared equals to q squared. Okay. And we have an obtuse angle triangle if p squared plus r squared is less than q squared. Okay, so basically what this is saying is that if the longest side squared is greater than the two other sides squared, sum of the other two sides squared, then that means our triangle isn't a normal right angle, but it's actually opened up a bit more. So it's an obtuse triangle like that. Do you see? So this angle is greater than 90 if we have something like that. Okay. Now, if we have the top case where the hypotenuse squared is less than the sum squared of the other sides, then we have an acute triangle, which looks something like that. So that angle is less than 90. And if it exactly equals, then we have the theorem of Pythagoras that says that this angle is exactly 90 degrees. Okay. So guys, that's really the result going backwards. So what we can do is now let's do an example and you guys are going to do the rest of them. Okay, so let's go to exercise 11.3, number 1. All right, so they draw us a triangle. They say classify each of the triangles showing all necessary calculations. The triangles have not been drawn according to scale. So when we say that, don't even think about looking at it and saying, oh, it looks like this or whatever. No, you can only take the information that's given, and that is the values and the numbers. Okay. Right, so we have a triangle that they drew for us that kind of looks very skew. So I'll draw it skew as well. This is 9, 13, and 11. Okay, those are the sides. They say we must classify this triangle. Excuse me. Right, so let's try to classify it. So we need to find out whether this squared is bigger, less than, or equal to the sum of these squared. Okay, let's find out. So 13 squared equals to what? 13 times 13 is 169. Okay. 9 squared plus 11 squared equals to 9 squared is 81 plus 11 squared is 121. And that equals to 100 and 202. Okay. So what do we find? We find that 13 squared is less than 9 squared plus 11 squared. Do you see that? Because 9 squared plus 11 squared is 202, and that is bigger than 13 squared, which is 169. So here I've just worked them out, and now I'm comparing. Right. Since we got this relationship that the hypotenuse is less than the other two sides, what kind of triangle do we have? Well, let's go back to our classifications. If our hypotenuse squared is less than the two other sides, and that's what we have, then we have an obtuse, no? Yes, an obtuse angle triangle. So, no, I'm looking at the wrong one. Sorry, guys, it's an acute angle triangle. All right. So the way that we've drawn it is actually incorrect because this angle isn't 90. It should be less than 90. Okay. But obviously we drew it the way they drew it because they meant to mislead us. Okay. All right, guys. So what you're going to do is for the rest of number 1, you're going to do the same procedure and you're going to classify what kind of triangle it is. Okay. Number 2, it gives you a parallelogram. It says 1, determine with reasons the values of A, B, C, and D. Okay, guys, when we say with reasons, state what theorem you're using, okay, or what result, like alt angles, angles on a straight line, and so on. And then classify triangle TQR, showing all necessary calculations. Okay, classify QTR, so tell me what kind of triangle it is, okay? So you can also think about equilateral, isosceles, and scalene when you classify these triangles. Okay, number 3 is looking at the reverse of the Pythagoras theorem. So that you guys have to work through and see where you get. And yeah, and that will take us to the end of this section and to the beginning of the revision section, which is the blue section on page 105. Okay. So I just want to see if I have another lesson with you guys. Yes, I'll see you again tomorrow. So what we can do is we can work through I'll skim through this revision thing tomorrow with you if there's something that I want to take note of. Otherwise, we're going to start with construction. So for the construction section, guys, when you watch this video, try to prep yourself a protractor, a compass, and all of these things. Okay, and we're going to be working with that. So yeah, constructions are not a very big section, but it is important. Okay. Right, cool guys. So for the homework, what I want you to do is exercise 11.2 and exercise 11.3, whatever we have not done. Okay, and then start working on the revision as well. Okay. All right, cool guys. I hope you enjoyed the video, and I'll see you next time.